All right, let's go ahead and talk about excited state versus ground state electron configuration. Now, what I will say is ground state electron configuration is the normal electron configuration that we've seen this entire time. And so, for example, lithium is 1s2, 2s1. And so what that means is that there's two electrons, up arrow, down arrow, in the 1s's, and then there's one electron in the 2s's. Now notice how the 2p's don't have any electrons. And then there's also the 3s's and 3p's. They're just not shown on here, but those also don't have electrons. They're empty. But what happens is electrons can actually absorb energy and jump to higher energy levels. And the way it absorbs energy is when a photon of light comes in, strikes the electron, and then the electron can jump up to a higher energy level by absorbing that photon. And what ends up happening is it will look like this. And so we are in a situation where an electron is in a higher energy state than it normally is. And that is said to be an excited state. So an excited state electron configuration is one in which an electron is in a higher energy than it should be. Now what I will say is this happens all the time, but what ends up happening is once it goes up, it will end up going back down at some point, and when it goes back down, it will release that energy in the form of light. So notice here, this electron configuration, notice how it is 1s1, 2s1, 2p1. And the fact that the 1s's are not filled, and that the 2s's are not filled, and that the 2p still has an electron tells you that it's in an excited state. So let's go and take a look at this here. So let's do some practice problems. So we want to determine if something is in the ground state or the excited state. Now what I'll say is the ground state is a normal electron configuration. So if you take a look here, you want to look, is that the normal electron configuration? And what I will say is this is actually not, it's actually an excited state. Because again, this right here needs to be completely filled before any 2p electrons occur. And so because it's not, that tells us it's an excited state. Now notice here, this right here is a normal electron configuration. 1s2, 2s2, 2p6, that's normal. And so this is a ground state. Now I want you to just take a look at C and D, pause the video, take a look at C and D, and just try to determine on your own if it's excited or ground state. So in this situation, you'll see that this is not the normal electron configuration because the 1s's are not filled. This is actually an excited state. This here is a ground state. Now, what we're going to do is we're going to do the same exact thing right here, except we're going to also determine what element it is. So let's go and talk about that. So this here is a ground state. And the reason why we know that is because it is a normal electron configuration. It's the normal order in which the electrons fill. This is filled, so that's okay. So it's good. Now, if it's the ground state, all you have to do is look at this last part here. If it's the ground state, all you have to do is look at the last part to determine the element. 2p5 happens to be fluorine. If you look at the 2p's and the fifth element in, it's fluorine. Now, this next one is excited. So this is an excited state. And the reason why is because this is not filled. Again, all of these need to be filled before the next one. And because it's not filled, it tells you it's an excited state. If it is an excited state, you cannot look at this. You cannot just look at that. The only way that you are able to determine the element is by counting the electrons, and these represent the electrons. So what you do is you add all of these together. And if you add them all together, you'll see it's 16. So you'll see it's 16. And all you do is look at your periodic table, and which element has 16 electrons? It's sulfur. So again, if it's an excited state, you have to add up all the electrons to determine what element it is. All right, again, this one's excited. And the reason why we know it's excited is because this is not filled. And again, all of these need to be filled before the next one. Now, again, if it's excited, you cannot look at this. If it's excited, you cannot look at that. You have to add up the electrons. And so 2 plus 2 plus 5 plus 2 is 11, which is sodium. All right, this one here, this is the ground state. Because it's the ground state, we can just look at that. And 3p3, if you look at your periodic table, is phosphorus. All right, number 3. Are these orbital notations ground state, excited state, or just wrong? And what I'm going to say is this here is just wrong. It's just wrong. This one is excited state. The reason why this is just wrong, by the way, is because this should be up arrow, down arrow, up arrow, down arrow. And then this should be up arrow, up arrow. All right. So let's go ahead and let's talk about how electrons get excited. So lithium here has 2 electrons on the first energy level, and it has 1 on the second. All right. So again, lithium has 2 on the first energy level and 1 on the second. So this here is the ground state electron configuration. Now what ends up happening is a photon of light will come in, and when it comes in, it can be absorbed by any of those electrons. But let's pretend like it's being absorbed by this electron. Now what ends up happening is this electron will then jump up to a higher energy level. And we end up with this being in a higher energy level than it should be. Now, what'll end up happening is that after it jumps to a higher energy level, it will actually fall back to where it is supposed to be. And when it falls back to where it's supposed to be, it will release that energy back in the form of light. And what we end up with is a ground state electron configuration and a photon of light that's given off. So to recap, we've got our normal electron configuration. An electron will absorb energy in the form of heat or light and jump up to a higher energy level. But when it falls back down, it will release that energy in the form of heat or light, and then it'll be a normal electron configuration again. So again, it absorbs energy and jumps to a higher energy level, and then when it falls back down, it releases that energy. And that's it when it comes to electron configuration.